Now, for the remaining hydrocarbon derivatives, in past years, what I have required my students to be able to do is to name them. But because we are running short on time, what I'll be requiring you guys to be able to do this year is to be able to recognize those structures and identify what they are. And so in this case, the very first category that we're going to be taking a look at is the ether. Now, if you take a look at the ether, what it involves is essentially an O that is built into the carbon chain. So unlike the alcohol where you have your 3 carbons and then you have an O and H sticking out of that main chain, what you now have is you have an ether where the oxygen is actually built into the chain. And so if you take a look over here, you have these 3 carbons, but in the middle of it is that you have this oxygen that has become part of the overall chain. So when you see something like this, this is considered an ether. Now, when you take a look at this in the actual molecule that is drawn, what you're going to see is that you have this O that is built in to the overall chain. And so that is going to be your key for remembering what an ether is. Now, if we take a look at the rest of the different hydrocarbon derivatives, what we're looking at are basically hydrocarbon derivatives that are centered around the carbonyl group. Now, what is the carbonyl group? The carbonyl group here is a carbon with a double bond O. So if I was to show you this structure over here, you have essentially this carbon and then you've got your double bond O, and then you've got these 2 bonds that are connected to other things. And so in this case over here, where this carbon and double bond O lands will then affect what kind of molecule you have. So the very first category that we're taking a look at is this carbonyl group with an H. And so in this case, I'm going to show you the 3 carbon chain, but now you have a carbonyl group. So this is carbon with a double bond, oxygen, and then at the end over here is you have your hydrogen. Now, when you take a look at this, you must recognize that you have that carbonyl group with the hydrogen, and it is quite unlike the alcohol. And I'm just going to put this molecule in here just to show you is that you've got this carbon, you have the oxygen, and then the hydrogen is connected to that oxygen. But this one over here, it is different in the sense that this hydrogen is coming off of the carbon, and the carbon over here has this double bond with the O. And so because of this group over here, we call this one here an aldehyde. So if you were to take a look at how it is represented, what you guys will see is that you have the C double bond H right over here, and then that is going to be your representation of your aldehyde group. Now, the next one that we take a look at is something called a carboxylic acid. So with the carboxylic acid, what you will have over here is you have the carbon with the double bond O, so there's your carbonyl group, and now instead of just an H, you're going to have an OH attached to it instead. And so in this case over here, to help you see the difference, right now you have a aldehyde right over here, where you have your carbonyl group right here with the hydrogen. And then now over here we have our carboxylic acid, and if you were to take a look, you have your carbonyl group here, but instead of being attached to a hydrogen, it's attached to another oxygen, and then it's finished off with a hydrogen. And so in this case over here, because of the addition of this oxygen, we now have a carboxylic acid. Now, when you take a look at the representation, which is in your notes, you're going to see that you've got this carbon with a double bond O, and then you have an OH. And so this is going to comprise of your carboxylic acid. Now, when you take a look at other ways that this is represented, I'm just going to just quickly draw this right over here, is that you're going to have your carbon, and then let's say we're going to have carbon, and then it's going to be followed by 2 O's and then an H. This is also another way that the carboxylic acids are represented. Or if I was to expand this, this would be CH3, and then this would be C with a double bond O, and then you have an O, and then an H. And so this and this are representing the same structure. And so that is something that you need to be aware of when you're taking a look at carboxylic acids. Now, when we now take a look at the aldehydes and the carboxylic acids, one of the things that you have to recognize is because of the way that they're structured, you can no longer have a carbon chain extended off of the hydrogen of the carboxylic acid, nor are you able to have another hydrogen extended off of the aldehyde group, which is over here. And so therefore, when you take a look at these two groups, they're always going to be found at the terminal carbon, and they cannot be located anywhere else on the carbon chain. And so that is something that is really significant about these two groups, the aldehyde and carboxylic acids, is that they are terminal groups. So when we come back to the next video, you're going to see the different hydrocarbon derivatives for the carbonyl group that is inserted within the carbon chain.